Okay, so have you ever heard a story so wild that it makes you just stop and say, wait, what?
Oh, I'm sure we all have. The kind that makes you question if it's real or just too good to be true, right?
Exactly. And the one we're diving into today, well, it definitely falls into that category. Back in March 2003, the FBI arrested this guy, Andrew Carlssin. Sounds pretty normal so far, right? But here's the catch. He had turned a measly 800 bucks into, get this, $350 million in the stock market.
Wow, that's quite a return on investment. I'm guessing it didn't take him years to do that.
Nope, not even close. We're talking about 2 weeks.
2 weeks.
Now, that is something else. I could already see why the FBI would be interested. Those kinds of gains, it just screams insider trading or some kind of sophisticated scam.
That's exactly what they thought. They were sure he was up to something shady. But when they questioned him, Carlson dropped a bombshell. He claimed he was a time traveler from the year 2256. Said he knew how the market would perform because he'd seen it, well, in the future.
Now, that's a story for the ages. Talk about an unexpected defense. Did the FBI buy it? Not a chance. They thought he was playing them, spinning some elaborate tale to avoid charges. So, naturally, they started digging into his past.
Makes sense. You'd want to see if there's any evidence to support his claims or any history of similar, outlandish behavior.
And here's where things get really weird. The FBI, they couldn't find any record of him before December 2002. It's like he just popped into existence a few months before hitting the stock market jackpot.
That's more than a little strange. It certainly adds fuel to the fire, so to speak. Makes you wonder if there was more to his story than they initially thought.
Hold on, it gets even wilder. Carlson was released on bail, and while awaiting his hearing on April 3rd, he disappeared, vanished without a trace. Never heard from again.
Wow, talk about a plot twist. So we're left with this big unanswered question. Was this guy actually a time traveler who, I don't know, maybe went back to his own time? Or was this just an incredibly elaborate hoax that spiraled into an urban legend?
Right. It's one of those mysteries that just sticks with you. And that's what we're here to explore today. Let's set aside the speculation for a moment and dive into the actual science of time travel. Is it even remotely possible, or is it purely the stuff of science fiction?
It's an age-old question that continues to capture our imaginations. We want to unpack those scientific concepts, separate the fact from the fiction, and see if there's any real basis for the idea of manipulating time.
Exactly. Now, when we talk about time travel, we can't ignore the massive impact of H.G. Wells's The Time Machine. That 1895 novel basically introduced the concept to the world, and the term time machine itself became part of our vocabulary.
Wells's work was truly groundbreaking. It took time travel from a purely philosophical concept and turned it into something that, at least in our minds, seemed achievable through technology. It gave us this tangible image of a machine that could transport us through time.
And from there, science fiction just ran with it. We see so many different types of time travel depicted in movies and books. You got the one-way trip to the future like in Interstellar, where the characters travel through space, encounter a black hole, and when they return to Earth, decades have passed.
Interstellar does a great job of visually representing the concept of time dilation, which we'll definitely get into. The idea that time can pass at different rates depending on your relative motion and the gravitational forces at play.
Then there's the instant time jump, a staple of time travel stories. The DeLorean hitting 88 miles per hour and Back to the Future, or the protagonist and the girl who leapt through time who can just jump to different points in her life.
That idea of instantaneous travel through time is a fascinating one, although currently outside the realm of scientific plausibility.
And what about the kind of time travel where the traveler stays put, but time itself is manipulated around them, like Hermione's time turner in Harry Potter, where she can rewind specific periods while remaining essentially outside the normal flow of time?
The time turner introduces this interesting idea of closed time loops, where actions taken in the past are already woven into the fabric of events leading up to the present. It makes you think about cause and effect, destiny versus free will, all within this fantastical context.
Then we have the more, let's say, grounded approach to time travel, like in Primer. Those characters built a device, but they had to spend the same amount of time inside it as the length of time they wanted to travel back. A day in the box meant going back one day.
Primer, while still fictional, attempts to grapple with the potential constraints and consequences of time travel in a more physically realistic way. It highlights the potential for chaos and paradox, even with seemingly limited temporal manipulation.
And of course, who could forget Superman flying faster than the speed of light to turn back time? A classic comic book solution to save the day.
Ah, yes, the superluminal time travel trope. It's visually striking, but it goes against our current understanding of physics, specifically Einstein's theory of special relativity, which sets the speed of light as an absolute limit.
So we've got all these imaginative scenarios from fiction. But what about the reality? What does science actually tell us about the possibility of time travel?
Well, based on our current scientific understanding, traveling to the future appears to be far more plausible than traveling to the past. The two are very different beasts, so to speak.
Okay, so let's start with the future. This is where Einstein's theory of special relativity and this mind-bending concept called time dilation come in. Before Einstein, the prevailing view, largely thanks to Newton, was that time was this constant, universal thing, right?
Yep.
Ticking away at the same rate for everyone, everywhere.
Precisely. In Newtonian physics, time was absolute, unchanging, flowing uniformly regardless of an observer's motion or position within a gravitational field. A second on Earth was equal to a second on Mars, a second on a speeding train, anywhere.
But Einstein came along and said, hold on a minute, time isn't so straightforward. He famously compared time to a river. Its flow can speed up or slow down depending on factors like your speed or the strength of gravity around you. That, in essence, is time dilation, right?
That's an excellent analogy. Einstein's revolutionary idea was that time is relative, not absolute. It's interwoven with space to form this fabric we call space-time, and this fabric can be warped and stretched by gravity and motion.
Let's focus on the speed aspect first, known as kinematic time dilation. The faster you move relative to someone else, the slower time passes for you compared to them. It's hard to wrap your head around because we don't experience those kinds of speeds in our daily lives.
Right, at the speeds we're used to, these relativistic effects are so minuscule that they're practically unnoticeable. But as you approach a significant fraction of the speed of light, that's when things start to get really interesting.
There's this classic example using two highly accurate clocks. You keep one on the ground and send the other on a really fast airplane. When the plane returns, the clock that was flying will actually be a tiny bit behind the stationary clock.
It's a tiny difference measured in nanoseconds, but it's a real measurable difference. And this isn't just a thought experiment. The Hadi-Keating experiment back in 1971 actually did this using atomic clocks flown around the world on commercial flights. The results confirmed Einstein's predictions with incredible precision.
It's mind-blowing to think that just by traveling at the speeds of a regular airplane, you're actually experiencing a tiny bit of time travel into the future.
In a way, yes. It highlights how time is not this rigid, unchanging entity we might perceive it to be. It's fluid, influenced by motion.
And to be clear, time isn't actually slowing down for the clock on the plane, right? It's about how we observe it from different frames of reference. Time is relative to the observer's motion.
Exactly. If you were on that plane, your own clock would appear to be ticking at a normal rate. It's the comparison between the two clocks after the journey, viewed from a single perspective, that reveals the impact of their relative motion on the passage of time.
Okay, so let's ramp things up. If we could build a spaceship that travels at, say, 99.9% the speed of light, and someone spent 10 years on that ship when they returned to Earth, thousands of years could have passed. The source material mentioned a figure of around 9,000 years. That's basically a one-way ticket to the distant future.
That's the remarkable implication of time dilation at relativistic speeds. As you get closer and closer to the speed of light, the difference in the passage of time between the traveler and someone stationary becomes increasingly dramatic.
Which means, theoretically, traveling to the future is possible. We just lack the technology to achieve those kinds of speeds with humans on board.
That's the crux of it. The laws of physics as we understand them allow for it. The challenge lies in developing the necessary technology and energy sources to propel a spacecraft to such velocities while ensuring the safety and well-being of the crew.
And it's wild to think that even astronauts on the International Space Station experience a little bit of time dilation due to their high orbital speed. The Russian cosmonaut, Gennady Padalka, who holds the record for the longest time in space, is actually credited with traveling about 0.02 seconds into the future.
It's a tiny amount in our everyday experience, but it demonstrates that time dilation is a real phenomenon that occurs even at the speeds achievable with current technology.
So that's time travel into the future through speed. But Einstein also described another way to experience time dilation through gravity. The stronger the gravitational field, the slower time passes.
This is gravitational time dilation. Einstein's theory of general relativity explains how massive objects distort space-time, and this distortion affects not just the trajectory of objects, but also the flow of time.
Einstein used this brilliant analogy of a rubber sheet to represent spacetime. Imagine placing a heavy object like a bowling ball on that sheet. It creates a dip, a curvature, that's gravity. And the deeper the dip, the stronger the gravitational pull and the slower time flows in that region.
It's a helpful way to visualize how gravity warps the fabric of space-time. The more massive the object, the more pronounced this warping effect becomes, and the greater the impact on the passage of time in its vicinity.
Thinking back to Interstellar, that extreme time difference they showed on the planet near the black hole, where 1 hour for them equaled 7 years back on Earth, that wasn't just Hollywood making things up, that was based on real science.
Yes, Interstellar provided a visually compelling and scientifically accurate depiction of gravitational time dilation. The immense gravity of the black hole in the film warped spacetime to such a degree that time flows significantly slower for those close to it compared to observers further away.
And we know black holes are not just theoretical constructs anymore. That first image captured by the Event Horizon Telescope a few years ago was incredible proof that these incredibly massive objects exist.
Absolutely. That image marked a major milestone in our understanding of black holes. It provided direct visual evidence of these extreme gravitational environments, confirming decades of theoretical work.
So if you wanted to fast forward your personal timeline, hanging out near a black hole would theoretically do it, although I wouldn't recommend it for obvious reasons. But even on a smaller scale, like with the GPS satellites we rely on every day, they experience both types of time dilation due to their speed and their position in a slightly weaker gravitational field than we are on the surface. Scientists have to constantly adjust their clocks to account for these differences.
That's a great example of how time dilation is not just some abstract concept. It has real-world implications and affects the technology we use daily. If we didn't factor in these relativistic effects, our GPS systems would quickly become inaccurate.
Okay, so speed and gravity, those are two potential ways to reach the future. But the source material also mentioned cryosleep, the idea of freezing people to slow down their aging, especially for those long-haul space journeys. Is there any scientific basis for that?
Well, the underlying principle of cryosleep, or more accurately, suspended animation, rests on the idea that by significantly lowering body temperature, you can dramatically reduce metabolic processes. These are the chemical reactions that sustain life, but also contribute to aging.
So you're essentially putting the body into a state of deep hibernation, slowing down biological processes to a crawl. It's like hitting the pause button on aging, right? I know NASA's exploring something called the stasis chamber, aiming for a 2-week hibernation period for astronauts by inducing mild hypothermia.
That's right. NASA's research in this area focuses on the potential benefits of inducing a state of torpor in astronauts during extended missions. It could significantly reduce their metabolic rate, conserve resources, and potentially mitigate the harmful effects of prolonged exposure to space radiation.
And there was this incredible case in Japan where a man accidentally ended up in severe hypothermia and survived for 24 hours with no lasting damage. His body temperature dropped drastically, but he somehow recovered fully. It makes you think the human body might be more capable of handling these kinds of extreme states than we realize.
That case certainly highlights the remarkable resilience of the human body under extreme circumstances. However, it's important to remember that there's a significant difference between accidental hypothermia and the controlled, long-term suspended animation envisioned for interstellar travel. There are still considerable scientific and medical hurdles to overcome.
Still, it sounds like cryosleep could be a viable option for future space travel, especially those missions that would span generations. It's like a unique form of time travel, outpacing time by essentially slowing down your own biological clock.
It definitely holds potential, though it's still largely in the realm of theoretical possibility. There's a lot more research and technological development needed before we can safely and reliably induce and reverse long-term suspended animation in humans.
All right, so we've established that traveling to the future seems scientifically plausible, at least in theory. Now, for the really intriguing question, can we go back in time? The source material mentions Stephen Hawking's time traveler party experiment, where he sent out invitations after the party had already taken place. No one showed up, which he playfully took as evidence against the possibility of backward time travel.
Hawking's party was a clever and humorous way to address the paradoxes inherent in the idea of traveling to the past. If it were truly possible, why haven't we encountered visitors from the future?
It does make you think, doesn't it? But theoretically, Einstein's theory of relativity doesn't completely rule out the possibility, does it? It leads to these ideas of wormholes and closed time-like curves, or CTCs. That sounds like pure science fiction, but there's some serious physics behind those concepts.
Yes, Einstein's equations for general relativity, which describe gravity and the nature of spacetime, do admit solutions that could potentially allow for backward time travel. These solutions involve extreme distortions of spacetime, like wormholes and CTCs.
So let's break that down. Wormholes are like these theoretical tunnels that connect two distant points in spacetime. It's like taking a shortcut through the fabric of the universe. And CTCs are essentially loops in time, allowing you to, theoretically, travel back to a point in your own past.
That's the basic idea. However, these remain highly theoretical constructs with significant challenges and potential paradoxes.
One idea is that these wormholes could be created by incredibly strong gravitational forces, like those around rapidly spinning black holes. The gravity warps spacetime so intensely that it might create these tunnels, these shortcuts. And physicist Kip Thorne has even theorized that tiny wormholes might constantly pop in and out of existence at the quantum level.
Thorne's research explored the theoretical conditions necessary to stabilize and potentially enlarge these microscopic wormholes to make them traversable. But this would require enormous amounts of energy, including exotic forms like negative energy, which has anti-gravitational properties. Think of it as a sort of repulsive gravity that could push spacetime apart, potentially holding a wormhole open instead of letting it collapse instantly. We've never directly observed negative energy, so it remains hypothetical.
So even if we could somehow create and stabilize a wormhole time machine, there's another major hurdle: paradoxes. The classic one is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you'd never be born, so you couldn't have gone back in time to begin with. It creates this impossible loop, a logical contradiction.
The grandfather paradox highlights the fundamental challenges to causality that arise when we consider backward time travel. It throws into question the very sequence of cause and effect that underpins our understanding of how the universe works.
And there have been attempts to address these paradoxes. One is the many worlds interpretation, or the idea of a multiverse. It suggests that when you go back and change something, you're not changing your original timeline. Instead, you're creating a whole new, branching timeline, a parallel universe.
The multiverse concept provides a way to circumvent paradoxes by suggesting that each alteration to the past spawns a new, self-contained universe, thus maintaining logical consistency within each individual timeline.
Then there's the predestination paradox, which is sort of a fatalistic view. It suggests that any attempt to change the past was always part of the sequence of events leading to the present. Like in those time loop movies where you try to prevent something bad from happening, but your actions inadvertently cause that very thing to happen.
Yes, the predestination paradox aligns with a deterministic perspective, suggesting that events are predetermined and that any effort to alter the past is ultimately futile and will always lead to the same outcome.
So, considering these paradoxes and the lack of any concrete scientific mechanism to resolve them, the possibility of traveling to the past remains highly speculative.
It's a fascinating area of theoretical exploration, but one that faces considerable logical and scientific obstacles.
Which brings us back to our mysterious stockbroker, Andrew Carlssin. Was he a time traveler who somehow figured out how to navigate these paradoxes and then vanished back to his own time? Well, as it turns out, there's a twist to his story.
Oh, I'm intrigued. Is there more to this than we initially thought?
It turns out the entire story originated from a satirical newspaper called The Weekly World News, known for its outlandish and often humorous takes on current events. Basically, it was a fabricated story, what we might call fake news today. And this fictional tale somehow got picked up and reported by legitimate news outlets, further spreading the story as if it were true.
Ah, the power of a good story, even if it's entirely made up. It highlights how easily misinformation can spread, especially before the age of instant fact-checking and widespread internet access.
So it seems our time-traveling stockbroker was nothing more than a product of someone's imagination. It's a reminder to always approach extraordinary claims with a healthy dose of skepticism.
Absolutely. Extraordinary claims require extraordinary evidence, as the saying goes.
So, wrapping up our deep dive into time travel, it seems journeying to the future is scientifically plausible, though the technology to achieve significant time dilation is beyond our current capabilities. We already experience tiny bits of time travel due to our motion and the effects of gravity. And cryosleep might offer a future avenue for traversing vast distances and experiencing extended periods.
It's fascinating to consider that we're already, in a very subtle way, time travelers. Our experience of time is not as fixed and absolute as we might perceive it to be.
But when it comes to traveling to the past, the universe throws up some serious challenges, primarily those perplexing paradoxes. And while we can observe the past through the light from distant stars and galaxies, that's more like watching a recording than actually going back in time. Those fundamental differences between traveling forward and backward in time are still a major puzzle.
And while the story of Andrew Carlssin turned out to be fiction, it sparked a discussion about some very real scientific concepts.
It definitely did. And it leaves us with some intriguing questions. If traveling to the future becomes more accessible, what impact might that have on society and our understanding of time itself? How would individuals cope with experiencing time at different rates? Could the cumulative effects of even those seemingly small time dilations lead to unforeseen consequences for future generations?
It's a thought-provoking question. It highlights how exploring the science of time travel isn't just about the technology, but also about the potential social and philosophical implications. It forces us to reconsider our own place in the grand scheme of time and the universe, and that's something worth pondering.
Absolutely. And that's a wrap for our deep dive into time travel. Thanks for joining us as we explored this fascinating and often mind-bending topic.
It's been a pleasure. Until next time.